Hello and welcome to the Daily Space. My name is Dr. Pamela Gay, and I am here to put science in your brains. I apologize for the late start we've had today. It has been a bit of a chaotic morning. As you know, we are frantically mapping out the asteroid Bennu for the OSIRIS-REx team in an attempt to find places that are clear enough of rocks and boulders that we can safely take down our spacecraft, do a touch and go grab of rocks and boulders. Well, we're not going to grab boulders. We're going to grab soil and pebbles and then bring those samples back to Earth. Now, we're only going to be able to find those places with your help. And this world has so many rocks that it is breaking all of our software that we had written before the mission, before we realized just how rocky this asteroid is. And so I was up late last night with this. Oh, I think I figured out how to solve our software issue. And that meant that I had a slow morning this morning. So we were running a little bit behind, and tomorrow will be better, people. Tomorrow will be better. Now, me figuring out this problem means there may be a stream later today where I'm going to be coding and explaining just how some of our data works and how our data processing works in real time for you. But for now, we have science, and today's science actually starts with something that's mostly just a pretty picture release. A lot of times, the great observatories of the world and orbiting our world will take images that turn out to just be stunningly beautiful. And the reason they take those images is really scientific. Someone is looking at something in detail. But it takes a long time to go from taking these images to processing them and producing the scientific understandings. So sometimes they just release these pretty pictures with a description of, in broad terms, what it is that we're looking at. And those pretty pictures, well, become essentially news notes of, hey, look, there's something shiny and you can make it your desktop background. And this is one of those press releases. This object is about 100 light years from one edge of that swoopy letter S, which, because I play way too much Wizards Unite, looks like I should trace it to cast a spell. That particular swoopy bit is what they're referring to as the seagull. Wingtip to wingtip, it's 100 light years, or end of swoop to other end of swoop is about 100 light years across. And that swoopy cloud is SH2296. And this is glowing material that is heated up by extraordinarily young stars that are radiating away their light. And as they do, they're heating up all the hydrogen gas in this particular system. A lot of this gas is referred to as H2 regions. That's where the hydrogen gas is getting ionized. And there's a whole lot of active star formation going on. The distance to the system is about 3,700 light years, so I don't recommend trying to take this picture with your backyard telescope. You will not succeed. But for now, here is a pretty picture that we can share of a pretty galaxy, or in this case, a pretty nebula. And this comes to us from the European Southern Observatory's very large telescope. So maybe if you have a couple 8 meters hanging around, those 8-meter telescopes, they'll take this picture. Okay, so from here on out, it's all science all the time. And I have to admit that our first big science story of the day gave me a brainworm. The title of this press release is, I kid you not, Revealing Quasars' True Colors. Now, anytime you say true colors in astronomy, it's tricky. And the reason that I say that is our eyes have a very specific response to colors. And when we look at the world around us, what we're doing, if you have completely regular everyday eyeballs, you're looking at the world through cones that essentially see red or green or blue, and they combine their sensitivity to these different colors. And exactly what colors you see varies person to person. Some people only really effectively see two of these three colors and they're colorblind. Some people see more colors, they're tetrachromal. But your brain is sensitive to these specific kinds, not your brain, your retina is sensitive to these specific sets of wavelengths, and your brain combines all this information to create a full color picture of the world. Well, when we're taking pictures of the universe, we do something kind of similar. We pass the light through filters, and then we recombine that light to try and create something that is either scientifically meaningful or is, in this case, trying to recreate, what colors we might see if we were in the neighborhood of the object and able to see it without all the gobbledygook that is between us and it. Now, quasars are typically very distant galaxies that have deep in their core a black hole that has feeding into it a spiraling density of gas and dust, an accretion disk. And that accretion disk is superheated, super dense, giving off its own light, and is making the center of these galaxies sometimes brighter than the entire rest of the galaxy combined. In fact, by definition, it's making it brighter than the entire rest of the galaxy combined. Now, the issue is, since so many of these are so far away, there's a lot of both our own galaxy's gas and dust between us and them, and there's stray clouds of gas and dust throughout the universe between us and them. And these clouds of material act to scatter out blue light the same way our own atmosphere scatters blue light in all directions, giving us a blue sky. And this means that when we look at quasars, the color that we're seeing is affected by all that gas and dust. Now, the other thing that affects it is, of course, the expansion of the universe, and then adding difficulty to the situation, it's all rotating, and the part that's rotating towards us gets shifted to the blue, the part that gets shifted away from us is shifted to the red. And if one side of that galaxy is more obscured than another, we're going to see, different amounts of blue and red light. Now, it's long been assumed that when we see quasars, and this is just an artist's illustration, and we see them and they're extraordinarily red once you've corrected for the expansion of the universe and the nearby gas and dust that we see, it's assumed that the reason they appear red is the gas and dust that's within the system obscuring that internal, light source of an accretion disk. It's further assumed that when we see one that's super blue, that's because it doesn't have as much obscuring gas and dust. Well, it's now thought in a paper that comes to us from Durham University that these colors might have a slightly different source. And this is that when that accretion disk in the center of the galaxy is particularly active at feeding, the energy of the material is pushing things out so much that it's actually blasting clear the center of that galaxy, allowing us to peer in more effectively. So when we see a blue one, it just means it blasted out all the nearby stuff. More is yet to be known, and I have to admit, I did not prep as well as I might have liked for today's show. I will be, after today's show, going through and reading these press releases in much more detail to create show notes that will go out to all of the patrons over at patreon.com/CosmoQuestX. So that is a superficial reading of the press release. More details to come. Now, in our next story of the day, I initially saw the two pictures, saw how similar they were, saw that both press releases rather, were referring to a new paper in the monthly notices of the Royal Astronomical Society. And I thought, well, they must be referring to the same paper because they're both talking about quasars. That's actually not the case. This month's monthly notices has two major papers with two press releases, both talking about these quasars scattered throughout our universe and how we can understand them in a variety of different ways. This second paper, with completely different artwork, comes to us from the good folks at the University of California, Santa Barbara. And what they've been looking at is, can we use geometry to understand how a bunch of different galaxies may all be the same kind of galaxy seen in different orientations? Now, this is a picture of a flattened disk system, a spiral, a disk of some sort. And when we look at these systems, there's a jet down in the center that is blasting out. There are large clouds of gas and dust that are going around the inner part of this system. And it's thought that when you look at these systems edge on, the disk of the galaxy prevents us from seeing down into the core and seeing those large clouds of gas orbiting the black hole in the center. And when we see the galaxies face on, or closer to face on, what we're able to do is actually see those massive clouds. Now, because those massive clouds are on fairly large orbits compared to the accretion disk, and because they're orbiting rapidly, we're able to see their motion as creating broad emission lines. They're broad because they're rapidly orbiting. And they're just far enough out from the center that they get blocked when the angle is anything other than steeply angled. And you're seeing how many notifications I'm getting right now. Now, the way to prove this is to figure out how to peer into the centers of one of these edge-on galaxies. And what the scientists at UC Santa Barbara managed to do was they realized that many of these systems that don't show those broad absorption lines, they only show narrow emission lines. Those are associated with the accretion disk down in the center and the jets. It's assumed that the ones that only show these narrow lines, if you look at them hard enough, well, some of their light is what's called polarized. This means the light is reflecting off of a surface. In this case, the surface the light is reflecting off of is all of the material associated with that jet. So you have an edge-on system that has a jet of material coming out, and these broad absorption line creating orbiting clouds. And some of the light from these clouds that are going around shines up onto the jet and gets reflected towards us as polarized light. So UC Santa Barbara scientists managed to filter out everything but the polarized light from some of these quasars and figured out that hidden in that polarized light is those broad absorption lines. So they were able to essentially look at reflected light from the inner part of the galaxy that was getting blocked by the outer part of the galaxy, allowing them to definitively prove, I think, as an observer, that the systems that do and don't show these broad absorption lines really are the exact same type of system, just seen at different angles that either allow you to directly see those broad absorption lines or to have them blocked. And this is just cool. People have been theorizing that these two types of systems are the same kind of object, technically called Seyfert Type 1 and Seyfert Type 2 galaxies. They've been theorizing they're the same thing for going on over a decade, but they hadn't been able to prove it. And this seems to me to be observational proof. So kudos to a job well done. Now, again, looking for things that are hidden. A team of researchers led by Tao Wang of the University of Tokyo, who also works at the French Alternative Energies and Atomic Energy Commission and the National Astronomical Observatory of Japan, they looked at Hubble's latest deep dark field, and they went looking to see if they could find superfaint galaxies. And there were superfaint galaxies found optically. But then they looked at this field with the Spitzer Space Telescope that looks in the infrared. And using that telescope, they now started to find 63 objects that glowed in the infrared, but the Spitzer Space Telescope didn't have high enough resolutions to allow them to figure out exactly what these 63 objects were. So they peered at these 63 systems with the Atacama Large Millimeter Array. This is that same system that has such high resolution that we've been imaging details in dust disks in star systems forming planets. Well, when you look far across the universe instead, this telescope array was able to make out the details of not all those 63 objects, but of 39 of them, which turned out to be extraordinarily bright radio sources. So these 39 objects in the far distant universe look like they're massive elliptical galaxies that are actively forming stars, but are so rich in gas and dust that they don't appear bright yet in the optical. They are just infrared still, they're radio still. We have giant molecular clouds in our own solar system that are kind of like this. You look at them in optical light and it's like, yeah, there's nothing. But as you go to longer and longer wavelengths of light that are able to pass through that gas and dust, suddenly star-forming regions appear. Suddenly stars appear. Well, now, with Spitzer and Atacama, they're doing the same thing to distant galaxies. Now, it's not like these galaxies look like very much. They're the blobs in this particular image. But it's still cool work. And what was particularly interesting is there appear to be 10 times more of these elliptical galaxies just starting to have star formation than there are of optical systems. And our models for how you get from the Big Bang to the modern universe were able to explain the presence of those optical galaxies, because we knew about them, so we wrote the theories to match. But they don't explain this large number of hitherto invisible galaxies that we're now finding using other wavelengths of light. So we need to work on our understanding of the expansion of the universe, the evolution of the universe, the formation of galaxies and stars and everything in between. Because it turns out the universe is a whole lot weirder and more diverse than our theories imagined. This is an ongoing problem. This is an ongoing problem, people. But we're working on figuring it out. So that's what I've got for today. And as I said, this show was not prepared quite as well as I would have wished, thanks to the Bennu asteroid being a pain in the... and keeping me up late at night as I tried to figure out how to solve a software issue. I will be completing these stories and getting you better show notes. Now, that's all the science I've got. And I will now hang around to answer your questions. And while you type those questions in, I want to let you know that we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. The Daily Space is hosted by myself, Dr. Pamela Gay, or Annie Wilson, our own binary ablaze. We come to you with the Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. In addition to the daily space, here on CosmoQuest X on twitch.tv, we also bring you launches, landings, and all the other live events as they happen, unless they happen at 4 a.m., in which case we just sleep. I'm sorry. In addition to that, Annie brings you the Sunday Science Hour every Sunday, more or less. We are produced by Susie Murph, who is ever patient with all of our shenanigans, getting her notes and things late. And we are so grateful that she is out there and we are able to pay Susie and Annie to do all the things that they do because of you. We are a user-supported, viewer-supported, rather, show. Your bits, your donations, your subs, your patronage over on patreon.com/CosmoQuestX is tax deductible where the law allows and lets us pay a living wage. We are literally brought to you by you, and I want to share some of the names of some of our amazing patrons. We have in the category of those who stay for the credits, Richard Hendricks and Bill Nash. The page turners category is Mark Sykes, David Swenson, Frederick Sorg, and our patrons go on and on across the categories, with names getting ever smaller as we fit them onto these slides. And all of these names will be shown so that you can linger upon them in the YouTube video, which will be getting posted later on at youtube.com/C for channel/CosmoQuest. So yeah, we're here because of you. So thank you for all you do to support us. And I am now going to look through the chat to find your questions. Scrolling. I missed the first 4 minutes before the show actually started of chat. So if you said hello, hi, I'm sorry I missed it because I was late getting that started. Okay, let's see what we've got. Hello, DPI. Hello, Larry. Hello, Hanny Zwarverp. Hello, Crossbound. Oh, that's cool, Crossbound, that you didn't realize there was going to be a launch, but then saw it from Tampa Bay. Hello, Side Mount. Hello, DPI 209. Hello, Astro B London. Hello, Refs Matt. You have no video, Astro B London. I hope your video arrived. I'm glad to hear that many of you did have excellent audio and video. Yes, it is so good that it's a slow news week. Unfortunately, today, when I may have needed a slow news day most, it was not a slow news day. More will be coming. More will be coming. So Larry writes, I hear that there was a dwarf star discovered inside a red dwarf. How did they do that? I'd need to look at a link for that. I think more accurately what happened, if it's the kind of star I'm familiar with, is two white dwarf stars spiraled in close enough to each other that the heat each star was blasting the other star with was sufficient to expand out their outer layers to create a new single envelope that enclosed the two stars. This object may have been different. I'd have to see the exact press release, but white dwarfs reigniting themselves into a new star is a thing. You also occasionally will have a red giant star consume a nearby neighbor when it expands out. All things are possible and probably happened somewhere in our universe. Thank you for the follow, Astronaut. Thank you. DPI 209 makes the accurate comment. We don't even have true colors on Earth. It's a thing. It's a thing. Oh, Jandraloon, I did not know. There's really more colorblind people than people who are not. I know men generally are much more common to be colorblind. Is it only among men, maybe? Because women actually periodically are tetrachromal. I know I'm a tetrachrome. I don't know. I need to find out more about this. Arthur C. Clarke forever corrupted my American spelling. I'm sorry, Larry. Um, did I write stray cat gas and dust? I might have. I might have. Hey, Susie. Hello, Veronica Cure. Hello, Open Cage 5. There's new brain research that proves red is this. Oh, I wonder if there's new research showing that we all see the same colors. I don't know how that would work. I know the colors that we see vary with age. They vary with gender and they vary with genetics, which goes with the gender. Yes, Rose, that was pretty and interesting. It's true. So Nebula Cluster says, so a quasar is a supermassive black hole that is feeding just a state difference. Yes. And the quasar isn't referring to just the supermassive black hole. It's referring to the environment around it, that accretion disk of material that is flowing inwards, and as it does, getting such a high density in some cases that it lights up with its own nuclear reactions, just like it was a star. So yeah, it's just a state change. Our own Milky Way doesn't have that accretion disk. It's not spiraling in actively, and so we don't have this wild glowing gas. Art of Space used an icon I cannot understand that appears to have a word, but it's a color that does not show up on the background of my iPad. Okay, looking to see. Thank you for the bits, Trekker Kev. I actually have a douche with me. Let me see if I can get him to... Here, do you want some bits? Don't take my douche. Come here. Come here. Stand on up. Okay, here we go. He can have bits. I'm not throwing them because he was about to take out my camera cable and my sound cable. Thank you for the bits. This is Eddie. We are going to hopefully next week be able to have all the dogs down here. Right now, he's the only one that is voice controlled well enough to not go places he shouldn't in the basement. Okay, let's see. Pain the asteroid, yelled by 10-year-old me. Yes, Bennu is full of hate and rage and making us full of pain. It's true. It's true. Thank you, DPI209, for being such an awesome person at keeping up with all of the text that needed to be shared out today. Oh, hey, Wayne Johnson. Thank you so much for the bits. You want some bits? Do you want some bits and bits and bits? Come on up. So good. So good. He's my baby. He's my baby. Yeah, so Susie Murph is responsible for the credits and the improved video editing that is happening, and it will get even better. Our instro, Dave Ballard, was visiting the past few days here in Edwardsville, as you saw on the stream. And he is currently the computer fairy. He is ferrying some of CosmoQuest's equipment that is not currently in use by students here in Edwardsville, because we don't have students here in Edwardsville right now. So he's ferrying the equipment to Annie and Susie, and they will hopefully be able to do improved work with improved technology to support them. Okay. I'm scrolling to see what else we have in here. Kerbal, it's all right to be impressed by the moon in your backyard telescope. I find looking at the moon, especially through like a 10 millimeter eyepiece where you can see along the terminator, the mountains and the shadows they cast, just a tremendous experience. So keep on keeping on with your backyard telescope. Yes, Handy's Vorverb, I see extra colors, or I see more subtle differences between colors. I'm that person that can tell if you are off by one character typing in your hex code for your screen colors. I am that person. Yes, we have Eddie. Thank you, Veronica Cure, for the bits. Eddie has now learned that when I say thank you in the correct tone of voice, he's going to get bits. Come on up. Here you go. Here you go. Hi. Hi. You're good. You're very good. He's very good. He's a very good boy. So that's all I've got for today. As I said, I am going to type up the notes before I go up and get lunch. So if you follow us over on patreon.com, you'll be getting full notes in a while. And later on today, I will likely be live streaming while I code and explaining out what I'm doing so that you can understand exactly how we take all the data that you submit and we turn it in to the awesome sauce that is the science for Bennu mappers. So thank you all for being here. And just to say it one more time, we are, wow, I need glasses. We are a production of the Planetary Science Institute working in collaboration with Youngstown State University. The Daily Space comes to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That's 6 p.m. London time. And on Sundays, our own Annie Wilson, Binary Ablaze, brings you the Sunday Science Hour. And in between, we bring you launches, landings, and every other bit of science that we can that occurs during normal human hours. And we're brought to you by you. We are supported through the generous contributions of viewers like you. And because of you, we are able to pay Annie and Susie a living wage, for which I am forever grateful. So thank you. And if you can't afford a monetary contribution, that's okay. Please go map Bennu. It's all right to hate it. It's all right to hate every moment of mapping it. But we kind of need to map all the rocks and measure all the boulders so that we can find the safe place to touch down for a moment with our spacecraft, grab a soil sample that we can then bring back to Earth. So before I get any more tongue-tied today, because really I'm working on maximizing my tongue-tiedness, it appears, I'm going to see if I can open up the credits and say thank you digitally and then go find someone to raid. If any of you can look and see who is currently streaming, I will happily go raid them. I think I saw earlier today that Rocket Sage was streaming. If she's still live, we will go stream her. So can somebody let me know? Can somebody please let me know? These are the things I need to know. Oh, bother. I have a request for oh, bother. I can do that. So let me find the correct screen. That is not the correct screen. That is the correct screen. I don't have a keyboard. I'm going to run the credits and then run across the room to where the keyboard is and raid oh, bother. So wherever you are in the world, have a fabulous morning, evening, or afternoon, and go map rocks!